So today I'll be going over the electric circuits laws and dynamics unit. So this is an overall simpler unit resulting in very little actual calculations and stuff. So the foundation of the law is based on three conservations. So the conservation of energy, where its energy is supplied by the EMS must equal to the energy dissipated, which means that the energy that goes in the system must also go out. So the potential difference reflects the energy change per unit charge. This potential difference is also called volts. Let me switch a color, a more bright color. This is also called volts, where volts has the same unit as joules per coulomb. What this means is that a volt is basically how many joules per electrical charge, like per unit charge. And the second conservation is conservation of charge, so electric charge is neither destroyed or created. And the total charge entering an element must equal the total charge. So if, like, say this one point, right, one singular point, one charge entered, then one charge must leave, to leave it as a net zero. And the movement in charges, current is the rate of flow of charge through a medium, typically driven by a potential gradient in the field, which this is measured by amperes. This is an A, sorry. Measured in amperes, which is basically the speed, like the flow, rate of flow. Also calculated in coulombs per second. So, in this fundamental of V, volts, like the volts, in potential difference, I is the current, and R is the resistance in a circuit. Ohm's law connects all of these together by saying that V equals IR. This is one of the most fundamental formulas inside this unit. And inside Kirchhoff's rules, one is the conservation of charge, as I talked about, and one is the other is conservation of energy. So the conservation of charge is basically the currents all equal, and the conservation of charge is that the volt difference is zero. Next is the resistors. So resistors are basically resistors offer resistance inside a circuit. So, for example, if it's connected in series, the resistance total is just all the resistors values added up. And if it's in parallel, then all of these are just voltage is identical. Okay, so in series, each of these have the same voltage, and there's also a current going through all of these, right? V2, I2, Vn, In. So over here, the voltage total, Vt, equals to all of these added up, Vn. And the current is always the same inside of these. I1 equals I2 equals I3. Always weight equals to In. So that is basically series. And in parallel, resistance, all of these also have a V1, I1, V2, I2, Vn, In. So over here, the V total is equal to, so like the V that is given by the battery. So V doesn't change. And the current adds up together. So I total over here equals I1 plus I2 all the way to In. And the resistance is calculated by the total resistance of the circuit over 1 equals all these resistance added up. R1 over 1 plus R2 over 1, Rn over 1. So over here we have the whole summarized values. we have the entire summarized values over here. So over here, what are used to actually measure these values? So to measure the volts, we use a voltmeter. And to measure the amperes, we use an ammeter. And to be connected in a circuit, ammeters must be connected in series. So let's say this is an A. And in voltmeters, it must be connected in parallel. So like, it must be connected in parallel. So like, there's gotta be something else. This is connected to like all the other things, like a resistor, maybe like, and then the other thing must have two branches. So one's over here, the V, one's like the other. And then the other thing is capacitors, which means that in a series, it is basically like the resistance in a parallel connection. But in a parallel connection, the capacitance is basically like the voltage in a series. So yeah, just remember this.